lies inside these two spheres. I can tell they're spheres because x squared, y squared, and z squared all have the same coefficient. They all have a coefficient of 1. So, so let's first find what the centers and the radii of the spheres would be. This one's easy. What's the center of this one? The origin. And what's the radius of it? 2. Okay. So over here we're going to have to do completing the squares. So x squared plus 4x plus y squared minus 2y plus z squared plus 4z, and in terms of our constant, the only constant is 5. I'm gonna put the 5 over there for right now. So I'm going to fill this in with a 4. What's half of 4? 2. What's 2 squared? 4. What will I fill this in with? 1. And what will this get filled in with? 4. So I added 4. I added 1. I added 4. So now this side is 4, right? And x plus 2 squared, y minus 1 squared, z plus 2 squared. And so the center is negative 2, 1, negative 2, and my radius is also 2. That radius is 2, that radius is 2. This problem is a bit easier because they have the same radii. If the radii are different, we'd still basically do the same thing, but it'd be a little more complicated. Okay, so let's graph both of those. So I'm going to just do graph implicit. Oh, will it? Well, I can start with graph implicit. So x plus 2 y minus 1 z plus 2 equals 4. I'm sorry, what?
I said they should be intersect. They're both radius 2, and one of them is
Well,
away from the
one
center.
has the origin, the other one.
Oh,
center.
they each have a radius 2.
They each have a radius
They can go towards each other, so the radius is both radiuses.
Yeah, let's
They'll
see,
intersect.
the distance of this from the origin would be 4 plus 4 is 8, 9.
It'll be 3 away from the origin, but they both have a radius 2, so they'll have an overlap.
Oh. Hang on. Why did it not? There we go. And actually, I don't need the, our radius is 2, so probably negative 5 to 5. I'll try it. Okay, so there's the one. You know, it's kind of transparent now. It's like the other day because we were trying to plot the points and the one point was inside, you couldn't see it. So I wonder why it's kind of transparent now. All right, the other, I think with here, like I'm not, well, hang on. Oh, hang on. That's, okay. And then,
Oh, that whole box is for function 1. So you have to pull up a separate
Well,
box.
I'm trying to see if, otherwise I can solve for Z. I just was trying to see if I can, let me change this to a plus. And change that to a 4. And then I'll remove. And then I will graph, so that's the 1. And then we'll go down and pick this one. Oh, shoot, it only does one at a time.
You see up at the very top, it says implicit surface number 1, you have to bring up, a separate window for implicit surface number 2.
Ah, yeah, you're right, okay. So if we change this to a plus, and that to a 4. Okay, I see my mistake, all right? There we go. Okay. All right, I think we got it. Okay, so here are our 2 spheres. We can see that they're intersecting. Unfortunately, we can't exactly see their intersection, but you can, since we know what spheres look like, you can kind of, picture what the intersection is going to look like. So, they're intersecting each other, and their intersection looks kind of like that, but it's 3D. Okay, so picture kind of a football shape. That's what their intersection looks like. Or, I'm sorry, what were you saying?
Is this something that's the same as the last?
No, because see, their intersection's over here, and the y-axis is actually, I've got it all tilted around here. Okay, here's this is X, so Y is coming straight out at us, but, the football shape is what I'm kind of tracing right now, it's just we can't see it. Robert, I'm sorry, what were you gonna say?
I was gonna say, it's a lens shape.